Hello, today I'm going to be explaining how to do systems of equations using substitution. So first, let's start off with what a system of equations is. So basically, a system of equations is um, basically uh, two or more equations that have the same variables, essentially. So um, here's an example. So an example would be x plus y is equal to 14, and then 2x plus 2y is equal to 28. So as we can see, there's two or more equations because there's two here, and we have these equations. They both have the same variables. So there's x and y in this top equation, and x and y in this bottom equation. So that's essentially what a system of equations is. And there can also be more equations in the system. Um, there can be an infinite amount of equations. But in this case, we're just going to be looking uh, at two systems at systems equations with two equations. So let's start off with a practice. So um, the first problem I'm going to give you guys is this is practice. I'm going to be explaining this is y equals 3x plus 2 and x plus y equals 14. So as you can see, this is a system of equations as it has y in both equations and 3x and it has x in both equations. Those 3x and this x. So basically, what we're going to be doing is we're going to be using a method called substitution. And substitution, it's like basically what it sounds like. So let me quickly explain it. So as you can see here, we have this top equation, which is y equals 3x plus 2. So we could say that, so essentially, although we don't have the exact answer of what y is equal to, we know what y is equal to in terms of x, as y is equal to 3x plus 2. So since basically what we're going to do is we're going to substitute y into this bottom equation, because we know what y is up here, we know what it's equal to, so we're going to substitute it into this bottom equation. So if we substitute it into the bottom equation, essentially what we'll do is instead of writing y, we'll write 3x plus 2. So essentially what we'll be doing is we'll do x plus 3x plus 2 is equal to 14. So now we didn't change this equation technically. Although we changed the y to something that y is equal to, which is 3x plus 2. So this equation down here that I just wrote is still valid. So now this is normal equation. This is something that I'm sure you can solve, and it's basically just solving for x. So in this case, if you solve for x, you get 4x is equal to 12, and x is equal to 3. So now we did half of it. You solved for one of the variables. But in a system of equations, you're usually asked to solve for both variables. So you know what x is, but you don't know what y is. But lucky for you, you know you have y in terms of x here. So basically, you can just plug in this x equals 3 back into this top equation, this y equals 3x plus 2. If you plug that x equals 3 in, you'll get y is equal to 3 times 3 plus 2. So then, obviously, if you just multiply this and add this, you'll get y is equal to 11. So the answer to this system of equations is y equals 11 and x equals 3. So that's essentially how you solve a system of equations using substitution. So just to reiterate, what you do is you find one variable in terms of the other. So in this case, we had y equals 3x plus 2. We found y in terms of x. Then we plugged in this 3x plus 2 as y. So essentially we got x plus 3x plus 2 equals 14 instead of x plus y equals 14. And then we solved for x and got 3. And then all you have to do is plug this x back into either of these equations, and I plugged it back into y equals 3x plus 2, and I know that x is 3, so I can just plug in 3 instead of x, and I got 11 just by solving that. So that's essentially how you do systems of equations using substitution. And if you guys have any questions on this, just put your questions in the comments, and I'll also have other videos about how to do systems of equations using elimination, how to do word problems using systems of equations, and how to use them using calculators, among other things. So please stay tuned and subscribe. Thank you.